Named after the Roman god of war, Mars is often referred to as the Red Planet because of the vast amounts of iron oxide on its surface. This iron oxide is the same compound that rust is made of and gives the planet its reddish hue. Travelling out from the Sun, it's the fourth planet you'd reach just after Earth, and the second smallest planet in the solar system just after Mercury. Whilst no planet has been studied as intensely as Mars, with observations dating back as far as the era of ancient Egypt over 4,000 years ago, when they charted the movement of the planet in the sky, scientists are still keen to find signs of life that existed long ago when Mars was warmer and covered with water. But given the challenges of its heavily cratered surface, thin atmosphere, and fluctuating temperatures, getting around poses some real challenges. One of the solutions is to design vehicles that can explore it for us. And this is where a cartwheeling desert spider could come to our aid. Professor Ingo Rechenberg is a German engineer who's been studying desert animals for over 30 years. Back in 2009, he discovered a new species of spider in the heart of the Shibi Desert in Morocco. Now, this is no ordinary spider. It's an acrobat, a spider that can avoid predators by tumbling to safety. In fact, it's the only arachnid we know of that has the ability to double its speed from 1 meter per second to 2 meters per second by simply cartwheeling away from predators. It can cartwheel downhill, uphill, or across level ground, hence its name. And as it was new to science, in 2014, the spider was named Cybrenus rechenbergi, after the man who found it. But Rechenberg much preferred to call it by another name, the flick-flack spider, after the German description for an acrobatic backward handspring. Kind of inventive. The flick-flack spider is a medium-sized huntsman spider. This is a group of spiders with long jointed legs which use venom to immobilize their prey. Our spider is nocturnal and feeds on moths which it catches before sunrise. Males measure up to 19 millimeters in length and females can be slightly longer. Both males and females are white with black markings on the underside of their legs. They spend the hot desert days in tube-like towers in the sand which they weave out of silk. But what really captured Rechenberg's attention when he saw this spider was its amazing movement. You see, Rechenberg is a German professor working in the field of bionics, which is all about applying the methods and systems found in nature to the study of engineering systems and modern technology. And seeing this spider gave him the idea of a cartwheeling robot, a robot which he believes could have uses in agriculture, on the ocean floor, or even on Mars. Cartwheeling across the desert here on Earth is one thing, but how does this compare with conditions on a planet over 54 million kilometers away? If you're enjoying this video, make sure you hit that like button. Liking the video does wonders for the channel and helps to spread this video to more people just like you. And if you're a fan of nature-inspired solutions and success stories like this one, 30 Animals That Made Us Smarter, the book, might just be for you. Check out the link in the description to order your copy now. All right, let's get back to the episode. Mars is described as a rocky terrestrial planet, very similar to Earth. In fact, all the rock and minerals identified on Mars are also found on Earth. The core of Mars may also be similar, but its exact structure remains a mystery. The surface is dry, dusty, and rocky. The southern half of the planet is rugged with massive craters and towering highlands. The northern half of Mars, however, has a flatter appearance with dry riverbeds and basins. Scientists suspect that oceans and lakes, which long since disappeared, are the reason for the smoothness of some of the areas, whilst ancient glaciers may have been responsible for carving out the terrain in other places. There are also ice caps at both of the poles that grow and shrink with the changing seasons. So, you can see why exploring Mars is such a challenge. You need a piece of kit which can cope with this diversity of landscapes. Rechenberg set about designing a 25 centimeter long model of a spider robot that could mimic the flick-flack spider, Whilst he believes this would be ideal for navigating the harsh surface conditions of Mars, it will need to have a little bit more stamina than the real spider. According to Reckenbeck, if the flick-flack cartwheels for more than 4 or 5 times a day, it can die of exhaustion. Reckenbeck worked with German automation company Festen to design his robo-spider, which they named the Bionic Wheelbot. And it looks, well, like something from another planet. It's much bigger than the real thing, of course, about 55 centimeters. That's roughly the length of an umbrella, compared with 2 centimeters. But like the real spider, it has 8 legs, all of which are controlled by 15 motors within the knee joints and body. It uses 6 of its legs when walking, but when it's time to roll, it does a somersault with its whole body, tucking in 6 of its legs and using the remaining 2 to push off the ground with every rotation. Thanks to its integrated sensors, the robot knows its exact position and when to push whilst rolling. Like the cartwheeling spider, this robot spider is much faster at rolling than walking. It can move itself forward even when on rough terrain, and it's this ability that could make the robot extremely efficient at navigating Mars's rough terrain. A one-stop shop for planetary exploration. But why is this somersaulting so important? Well, a robot with a tumbling or rolling motion allows more of it to be in contact with the surface it's moving over at any one time. This spreads its weight over a larger area, allowing for greater grip and weight distribution than either wheels or legs can offer, so it's generally more stable on irregular surfaces. Now, exploring Mars on the ground is one option, but given the terrain is so challenging, could we also explore it from the air? This might seem obvious at first. After all, gravity on Mars is about 1/3 of that on Earth. So flying there should, in theory, be really easy, right? Wrong. It turns out that the atmospheric pressure on Mars is less than 1% of Earth's, which means even with the advantage of lower gravity, generating lift is surprisingly difficult. But could the humble bumblebee have the answer? Dr. Chang Kwon Kang, an assistant professor at the University of Alabama in Huntsville in the United States of America, is working on a swarm of bumblebee-inspired flying robots, which he appropriately calls Mars bees. Now, the funny thing about using bees to design flying robots is that for more than 70 years, the way bees flew perplexed scientists. There's a popular misconception that dates back to the 1930s when French entomologist Auguste Magnon calculated that a bee's flight should be aerodynamically impossible. He argued that their wings were too small to get their fat little bodies off the ground. Bees, of course, do fly, but Magnon was onto something. If bees tried to fly like aeroplanes, then yes, he would have been right. Let's think about the basic principles of flight. Aeroplanes can fly because of a careful balance of 4 physical forces: lift, drag, weight, and thrust. In order to make flight possible, the lift force must overcome that of its weight, and the thrust needs to exceed that of its drag resistance. To do this, planes use wings for lift and engines for thrust. Drag is reduced thanks to a streamlined shape. Lightweight materials also help to achieve lift. Now, when you look at a plane, one of the things that stand out are its wings. They're pretty big and large enough to satisfy the lift equations for flight, which means they don't need to flap. But the small wings of a bee compared to its relatively fat body are not. But bees don't flap their wings up and down, which, to be fair, still wouldn't help them. Instead, bees flap their wings back and forth. Whilst an airplane's wing forces air down, which pushes the plane upwards, insects sweep their wings in a flattened spin. The angle of the wing creates turbulence or vortices in the air, like miniature hurricanes. The eyes of these mini hurricanes have a lower pressure than the air outside, and it's this which lifts the bees upwards. So there we have it. Problem solved. Well, not quite. Because of the ultra-low density in the Martian atmosphere, flying on Mars is far more challenging than flying here on Earth, as I mentioned earlier. So the first step for the scientists is to design a vehicle that can take off, hover, and fly in Mars's atmospheric conditions where the air density is 100 times lighter. To make up for this, it looks like the wings would need to be scaled up by about 4 times to increase the surface area they can use to push against the atmosphere. Remember, to generate lift, we have to push air down in order to counteract the weight of our vehicle and lift it upwards. So as air becomes less dense or becomes thinner, the more air you need to push down for the same weight you're trying to lift up. With the aid of sensors and wireless communication devices, each robot would be just one of a swarm of these insect-like machines. The beehive would be replaced with a mobile base serving as their charging station and main communication center. The hope is that ultimately these flying robots will be able to go out on their own, collecting all sorts of data, mapping the terrain and providing us with more information about the chemical composition of the planet. So, who knows? It might not be long before we have bee-like critters flying through the air and flick-flack spiders cartwheeling across the ground. And then I suppose Mars really would be home from home.
If you enjoyed this video, make sure you hit that subscribe button and head to the comment section to share the ingenious ideas that you've come across too. For our offers and much more, head to the episode description below. And if you're looking for more great content, then check out this next video. Thanks for watching.